Okay, we're doing OCR's paper 2 from November 17. This is a foundation non-calculator paper. And if we have a look at the grade boundaries, we need 47 marks for a 5 and 37 marks for a 4. Okay, question 1. We've got a probability question about a spinner, and we've got a probability scale underneath. And we're looking for, firstly, the probability of scoring a 2. Well, there is only a single 2 out of 6 numbers altogether. So the probability of a 2 is a 6th. This here, C, is definitely a half, which would be 3 out of 6. And this is definitely less than 3 out of 6. So I think the only option is B. Part B says, what's the probability of scoring less than a 6? Well, every single number is less than a 6, so that is definitely going to happen. The probability when something is definitely going to happen is 1, so that would be letter E. And then part C says the probability of scoring a 1 or a 4, well, there is 1, 2, 3, 4 1s and 4s out of 6, and 4 6 is the same as 2/3, so we want to be coming 2/3 along this line, and the only option is D. It's certainly more than a half. So question 2, we're looking at a hexagon and we're just looking for the lines of symmetry. Well, this would be a line of symmetry. So would this. So would this, just where there's a perfect reflection on both sides of the line. So we've got 3 lines of symmetry. Order of rotation symmetry for part B. We've got to imagine that this shape is rotating or spinning around. And we've got to count how many times it would look exactly the same. Well, if you think there's an arrow on top of there, and one there, and one there, etc., there is 4 times if this rotated around where it would look exactly the same as it does at the start. So, triangle has just one line of symmetry. So a triangle with one line of symmetry is going to look like this. And that is an. And then final part D, we're talking about parallelograms. And someone thinks that parallelograms have 2 lines of symmetry. Well, a parallelogram looks like this. I've purposely drawn it long so you can see this here is not a line of symmetry. If we reflected from one side to the other, it would not be a perfect match. Okay, so a parallelogram has no lines of symmetry. Question 3, we've got 100 gram packets of tea costing £4.16, and we've got a 25 gram packet of tea costs £1.05, and we're looking for the best value. Well, we've got quite nice numbers. If we look at the 100 gram for £4.16, and we'll leave that as it is, because then we can look at the 25 gram, and that is £1.05. If we multiply this by 4, we get 100 grams. And all we need to do is multiply this by 4 to see the equivalent cost for 100 grams. 4 times a pound is £4. 4 times 5 pence is 20 pence. That would be £4.20. We just need to answer the question, which packet is the best value for money? Well, this is £4.16 for 100 grams. This is £4.20 for 100 grams. The 100 grams for £4.16 is best. Question 4. We've got 8 buses at a bus stop, and this is the number of minutes late for each bus. So first thing I'm going to do is put these into order, because this question goes on to talk about median. So if I put these into order, and then we've got 2 bits of information about 2 more buses arriving. So 2 more buses arrive, and it creates a median of 3.5 and a mode of 0. I'm going to look at this mode of 0 first. That means there has to be more zeros than anything, so I'm going to throw another 0 in. If we look at this part here, we've got a median of all 10 buses is 3.5. So the median, the middle number when in order, has to be 3.5. So I'm going to start working into the middle and figure out where I'm going to go. So start crossing these off. Now I've crossed off 4 from each side. I am going to put an extra bus in here. And I know the middle of this 2 and whatever I'm going to put down has to be 3.5. Well, if I put a 5 in there, then the middle of 2 and 5, if we add those together, that comes to 7. And then if we half that, we get 3.5. So this 5 is correct. The middle of 2 and 5 is 3.5. If you're not quite sure what I did to work that out, try drawing a number line. Got the 2 that I started with, 3, 4. I'm saying the 10th bus was 5 minutes late. Can we find the middle of this? 1, 2. Yeah, it's right there, look, 3.5. Question 5, we're looking to write 0.26 as a fraction. Whenever you're converting a decimal to a fraction, it will either be out of 10, out of 100, or generally out of 1,000. And all we've got to do is count how many digits after the decimal point. Well, there is 1, 2 digits after the decimal point. So I pick the fraction with 2 zeros. So I'm going to write 26 out of 100. That is my fraction. It does say to give your answer in its simplest form. So I'm going to start halving these because they're both even numbers. I would get 13 out of 50. I know that 13 is a prime number. It won't divide by anything exactly other than itself and 1. So that is my final answer, 13 out of 50. Question 6, we've got some algebra to do. So first thing, we've got some brackets to expand. So this is just a multiplication. 4 times c is 4c. Then we've got to do 4 times 2d. Well, that would be 8d. 3 times 3c. 3 3s are 9, so that would be 9c. And 3 times minus 5d. Well, 3 5s are 15. 3 times minus 5 would be minus 15. That's going to be minus 15d. Let's make sure we collect any like terms. 4c added to 9c is 13c. And 8d, take 15d. You're starting with 8. You're taking 15 away. That's going to be negative 7d. Part 2, we've got to do 4a times 5b. Well, 4 5s are 20. And a times b is ab. Part B, we're looking at factorising. So we're looking for a common factor of 6 and 8. What's the biggest number that goes into 6 and 8? I think it's 2. And then these are different letters, so there's no common factor there. So I'm going to open some brackets and then say 2 times something is 6g. 2 times 3g is 6g. And then 2 times something is 8h. 2 times 4h is 8h. And final part, another bit of factorising. Common factor of 5 and 15 would be 5. 5 goes into both of those. Common factor of x squared and x, well, x goes into x squared and x goes into x. Open up some brackets. 5x times something is 5x squared. 5x times x is 5x squared. And 5x times something is minus 15x. 5x times minus 3. Question 7, we've just got some calculations to do, and it looks firstly that we're looking at bid mass. So the order of operations in which maths is done. This says brackets, indices, division, multiplication, addition, subtraction. And we can see we've got an addition and a division. Division comes first. So I must do that bit first. You're going to get 1 add 4 divided by 2 is 2. And then we can just finish this calculation. 1 add 2 is 3. Second part of the question, another bid mass question, but we've got some brackets, and brackets definitely come first. So do that bit first. We get 2 add 5 times. 8 minus 4 is 4. Still following BIDMAS, we've got an addition and a multiply. Multiply comes before addition, so I'm going to do this bit first. And we get 2 add 5 times 4 is 20. And then finish the calculation. 20 add 2 is 22. Part B, we're looking at 2 raised to the power of 5. And that just means 2 times 2 times 2 times 2 times 2. 5 times. Be careful with these. This is not 2, 4, 6, 8, 10. We've got to say 2 times 2 is 4. Times 2 again is 8. Times 2 again is 16. And times 2 again is 32. Part 2 of this is looking for the square root of 400. There's no real way of working these out. You just need to know them. 20 times 20 is 400. 2 2s are 4, and then 2 zeros on the end. So the square root of 400 is 20. And part C of this question, we've got an estimate question. And an estimate question, we need to round these numbers to one significant figure. So 23.1 would become 20, not 23. 3.9 would become 4. And we're going to divide by 8.12, which is 8. Now we're going to work this through. 20 times 4 is 80. And we're going to divide by 8. And 80 divided by 8 is 10. Question 8, we've got a pretty simple function machine. This is actually meant to be times by 30. And then add on 20. So we've got weight of a piece of lamb goes into the function machine with times by 30 and then add 20. So we're going to look at a piece of lamb weighing 4 pounds. We need to do 4 times 30 first. Well, 3, 6, 9, 12. And then just put a 0 on the end. And then we're going to need to add on that 20 minutes. So we're going to do 120, add on 20, which is 140 minutes. Part B is giving us the time that it takes to roast the lamb, and we're asked to work out the weight. So we need to work the function machine backwards. So if we come in the opposite direction, then rather than add 20, we need to take 20. And rather than times by 30, we need to divide by 30. So 95 minutes is what came out of the function machine. Let's reverse it. 95 take 20 is 75. And then we're going to need to do 75 divided by 30. So I'm going to set that up as a fraction. And what I'm going to do is just start dividing top and bottom to make my life easier. I think both of these will divide by 15. I know that 30 divided by 15 is 2. If I count up in 15s, 15, 30, 45, 60, 75, that is 5. And then 5 divided by 2 is 2.5. £5 shared by 2 people, £2.50. So that's my final answer. So in question 9, we've got a diagram of a garden. We've got a flower bed in the shape of a triangle. There's a lawn area and then a patio in the shape of a trapezium. And the rest of the garden, this bit, is lawn. And we need to find the area of the lawn. Well, there's several shapes we can work on, but we certainly can't work on the lawn because it's this weird shape. What I can work on is the entire garden. And I'm just going to do that now. So the garden is a rectangle. It is 8 meters high. And across the bottom we can see it's 10 meters across. So I can work out the area of that, which is just a rectangle. 8 times 10 equals 80 square meters. There is also a flower bed in the shape of a triangle, so we can work on that. And we know that's 2 across and 6 up. The area of a triangle is base times height divided by 2. So I'm going to do 2 times 6 and divided by 2. 2 6s are 12, divided by 2 is back down to 6. And then I can also work on this trapezium. So what we've got is a trapezium that's 3 meters across, 8 meters high, 5 meters across at the bottom, and then this side doesn't actually matter when calculating the area. The area for trapezium, we need to add these two opposite sides together, half my answer, and then multiply by 8. So I'll do that now. We're going to do 3 add 5, half that, and then multiply by 8. And what we get is 8 divided by 2 times by 8. 8 divided by 2 is 4, and 4 times 8 is 32. What we've actually worked out is the whole garden, the flower bed, and the trapezium. And if we take the whole garden and subtract the flower bed and the patio, then we're left with the lawn. So what we can say is the lawn is going to be everything. Take away the flower bed, take away the patio, and 80 take away 6 is 74, take away 32 is 42, and it would be meters squared. Question 10, we've got a pie chart and we've got the angles taken up by each way that people travel to work. So 72 degrees for cycle, 48 degrees for walking. It says find the ratio for the number of people who cycle to work to the number of people who walk to work. And we want our answer in its simplest form. Well, walking is 48 degrees. Cycling is 72 degrees. That there is your ratio. And we can start to simplify this. If we just half both sides, we would get 36 to 24. We can half both sides again. A half of 36 is 18. And a half of 24 is 12. And we can keep going, keep halving. Half of 18 is 9. Half of 12 is 6. And then finally, we can divide both of these by 3. So 9 divided by 3 is 3. And 6 divided by 3 is 2. Part B says 80 employees travel to work by car. So this 240 degrees is 80 employees. So let's write that down. And what we want to do, if we can, is see how many degrees each person takes up. So I know that 8, 16, 24. 24 is in the 8 times table. So I can quickly say 8 people is 24 degrees, just dividing both sides by 10. Then if I divide both sides by 8, well, 8 divided by 8 is 1. So one person is going to be 24 divided by 8, 3 degrees. So every 3 degrees represents one person. So now we're going to look at cycling. And I'm going to do this 72 degrees divided by 3. And that'll tell me how many people. So 72 divided by 3. How many 3's in 72? 3's into 7 is 2. Remainder 1. And 3's into 12 is 4. So cycling is 24 people. I'll do the same thing for walking. I'm going to do 48 divided by 3. So how many 3's in 48? And 3's into 4 is 1. Remainder 1. And 3's into 18 is 6. 16 people walk. Question 11, we've got Georgia, who is 4 feet 2 inches. And we've got a conversion that will change inches into feet. We're asked to use a different conversion, inches to centimetres, to work out Georgia's height in metres. Lots of different things going on here. What I might do first is change this 4 feet to inches purely into inches. So let's look at that. We've got 4 feet, 2 inches, and we know there are 12 inches in a foot. So these feet here, if I do 4 multiplied by 12, that will turn 4 feet into inches. So 4 12s are 48. Don't forget to add on this 2 here. Georgia is 50 inches. Now we know how tall she is just in inches. We can use this conversion to change her height into centimetres. So I need to say that she's 50 inches. And every inch is 2.5 centimetres. I need to multiply by 2.5. This is not as difficult as it might look. We're going to do 2 times 50, which is 100. And then 0.5 times 50 is just a half of 50. So I'm going to do 100 add a half of 50, which is 25. She's 125 centimetres. The final part of the question says we actually want her height in metres. We've got in centimetres at this point. Well, there are 100 centimetres in every metre. So we're going to need to divide by 100. And 125 divided by 100 is 1.25. Part B, we've got Owen who weighs 6 stones 4 pounds. And it says there are 14 pounds in a stone. So what I'm going to do straight away, just like above, is change Owen's weight into pounds only. So we've got 6 stones, 4 pounds. And every stone is 14 pounds. So we need to do 6 lots of 14. Well, 6 times 10 is 60. 6 times 4 is 24. I'm going to do 60, add 24, which is 84. Don't forget those 4 pounds as well. 84 add 4 is 88 pounds. We've then got a different conversion saying 2.2 pounds is 1 kilogram. So we need to convert Owen's weight in pounds into kilograms. So if Owen is 88 pounds, we need to do 88 divided by 2.2. We can change this calculation and do 88 divided by 22. That would be 4. 20, 40, 60, 80, 2, 4, 6, 8. So 88 divided by 22 is 4. Because this is a much smaller number, I'm sharing by a smaller number, meaning I'm going to get bigger answers in my actual calculation. So 88 divided by 2.2 would not be 4, but it would be 40. If this gets 10 times smaller than this, then the answer would get 10 times bigger. Question 12, we've got someone's carried out a survey of 50 students at his school, and he's asking if it's a good idea to have women-only railway carriages, and these are his results: 32 yes, 13 no, and 5 don't know. And it says what percentage answered yes. Well, yes is 32 out of 50. And we want to turn this into a percentage. The easiest way to get a percentage is to get your fraction out of 100. And if we multiply top and bottom by 2, we get 64 out of 100. As soon as we've got out of 100, we've got our percentage. Jack goes on to say, survey shows people in England think it's a good idea to have women-only railway carriages. Well, Jack only asked 50 people. So his survey or his sample is too small. Question 13 is quite a lot of information, but all of this is just explaining this diagram. And what we can see is because this diagonal goes through the corner of the small rectangle and the corner of the big rectangle and the centre, we're looking at two rectangles that are enlargements of each other. So these are similar rectangles. They're perfect enlargements of each other. And what we've got is the perimeter of the big rectangle is 40. So I know that all of this comes to 40. What I might look at is this perimeter and see what that comes to. Well, if the top is 6, the bottom is 6. If this is 2, this is 2. The perimeter of the green rectangle is 6 add 6, add 2, add 2, 12, 14, which is 16 centimetres. We know the perimeter of the large rectangle is 40 centimetres. I want to see how many times bigger the blue rectangle is compared to the green one. So what I'm going to do is a division. I'm just going to do 40 divided by 16. And if I half top and half bottom, that's the same as 20 divided by 8. Again, half top, half bottom, that's 10 divided by 4. Same again. That's 5 divided by 2. £5 shared by 2 people is £2.50. So this would be 2.5. So the blue rectangle is 2.5 times bigger than the green one. So what I can do is apply that scale factor to each side. If we just look at this, if I do 2 times 2.5, use money if you're unsure with your decimals, 2 times £2.50 would be 5. So if this is 5, this is 5. And then we can apply the same to this. We've got 6 on this green rectangle. So up here we need to do 6 times 2.5. Again, use money if you're unsure with decimals. 6 lots of £2.50 would be 15. So this is 15. And that is what we're asking for. The length and the width of the rectangle ABCD, the large rectangle. So the width would be 15 and the length is 5. Question 14, we've got someone cycling from A to B at a speed of 26 kilometers per hour. They then go from B to C at a different speed of 20 kilometers per hour. We've got some information about the time she set off and finished, and she doesn't stop at B. And then we've got a time here that it says X hours to go from A to B. So X hours from A to B. Why is the distance from A to B 26x? Well, if we know our speed, distance and time formulas, speed equals distance divided by time. This is talking about distance, and distance equals speed times time, which is 26 multiplied by x, which equals 26x. Part 2 asks for an expression in terms of x for the time taken to go from B to C. Well, if we look here, we know that total time is from 10 till 3, that's 5 hours. We know from A to B takes X hours. So from B to C, we'll have to do total hours, which is 5, take away this X. So we're just going to write 5 take X. We're then asked to show that the distance from B to C is 100 take 20x. I'm going to use this same idea from part 1 and say distance equals speed times time. We know the speed is 20 kilometers per hour. And we're going to multiply by time that we've just found. So 20 times 5 is 100. And 20 times minus x is minus 20. x. Final part of this question, we're told that the total distance is 118. Well, in part 1, we got the distance from A to B. And in part 3, we got the distance from B to C. So these two here are also the total distance. So we've got 26x added to 100, take 20x, and that comes to this 118. We've now got an equation we can solve to work out what x is. Well, 26x take 20x is 6x plus this 100 equals 118. If we take 100 from both sides, we've got 6x equals 18. And then if we divide both sides by 6, you get x equals 3. 18 divided by 6 is 3. So now we know what x is, we can answer this question. It wants to know what's the distance from A to B. Well, up here is A to B. And we know x is 3. So we need to do 26 multiplied by 3. 3 6s are 18, and 3 2s are 6, plus this 1 makes 7. 78 is your final answer. Question 15, we've got 2 marks just for knowing what the parts of a circle have called. The first part, A, is just asking for this line A. That is a line that touches the circle but never enters it. That's called a tangent. Part B, we're looking for this shaded region B. That there is called a segment. Question 16, we're looking at a sequence, so we need to figure out what's the next term. Well, hopefully we can see that 1 add 1 is 2. And then 1 add 2 is 3. The previous 2 terms add together to make the next one. This is a Fibonacci sequence. So we need to do 5 added to 8, which comes to 13. Sequence underneath, slightly different. I think that is times in by 2. That is times in by 2. And that is times in by 2. So I need to be able to do 64 times 2 to get the next term. Well, 2 times 60 is 120. And 2 times 4 is 8. Part B looks for an nth term expression for this sequence. Well, what we need to do is figure out what's happening between terms. I think from 15 to 12 we're taking 3. 12 to 9 we're taking 3. And 9 to 6 we're taking 3. The minute you've got this common difference, you can write that down and put an n after it, minus 3n. And what we need to do is imagine there's another number there. What would this be? Well, if I come this way, I'm going to add 3. And 15 add 3 is 18. And there's your nth term expression for that sequence. Question 17 is quite a lot of information, but it's all types of number work. We're looking for a number between 1 and 150. It's one more than a square number. So I'm going to start with my square numbers. The square numbers come from 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. I'm just going to continue that pattern. And I'm going to stop at 12 times 12 because I know 13 times 13 would be bigger than 150. So I'm just going to stop there. Go back to this information. It actually says I want one more than a square number. So let's do that now. I'm going to add 1 to this. Add 1 to this. Keep working through the question. The next line says it is 3 less than a cube number. So let's look at our cube numbers. Cube numbers come from 1 times 1 times 1, which is 1. 2 times 2 is 4, times 2 again, 8. 3 times 3 is 9, times 3 again is 27. And again, I'll keep that pattern going. And again, I'm going to stop at 125, which comes from 5 times 5 times 5, because 6 times 6 times 6 would be bigger than 150. Back into this line, it actually says 3 less than a cube number. So I need to do 3 less than these. Well, 1 take 3 is negative 2. I already know that's not going to be right because it's less than 1. But keep going. 8 take 3 is 5. 27 take 3 is 24. 61 and 1, 2, 2. The number that I'm looking for has to be in both lists. Now, it's not these numbers, and it's not these numbers. So it's got to be in the red list and the pink list. Well, 5 is in both lists, and 1, 2, 2 is in both lists. The final line says not a prime number. Well, 5 is a prime number. 5 will only divide exactly by itself and 1. 5 is prime. So my answer, the number I'm looking for, is 122. Question 18 is a bit of a strange one. We've got 2 terms and we're asked to factorise. And what we've got is something squared, and a subtraction between them. This is called the difference of 2 squares. If you factorise the difference of 2 squares, it goes into double brackets. This x squared term, I'm just going to put an x and an x in there. And this 43 squared, I'm going to put a 43 and a 43. And I'm going to add and subtract. This is how you factorise something called the difference of 2 squares. Square number. We've got an x in each bracket and a 43 in each bracket, and then just a plus and a subtract. That is finished. Part B, we've got the same thing going on. We've got something squared, so it's a square number. Something else squared, so it's a square number. And a difference, a subtraction. So it's difference of 2 squares again. I'm going to put the first thing into both brackets. I'm going to put the second thing into both brackets. And then there's an add and a subtract. Now, because we've got pure numbers here, we can actually work this out. 57 add 43 is actually 100. And 57 take 43 is 14. Now, when you've got a double bracket, you've actually got a multiplication going on between these two things. So we need to do 14 times 100, which is 1400. Question 19, we've got angles in a triangle in the ratio 1 to 2 to 3. And we're asked to show that the triangles are right angled, meaning we're looking for a 90-degree angle. Well, we know the angles in a triangle add up to 180 degrees. And we can split this total angles into this ratio. So if I draw 1 box, 2 boxes, and 3 boxes, that's my 1 to 2 to 3. If I share 180 across this diagram, it's showing me I'm going to do 180 divided by 1, 2, 3, 4, 5, 6. So 180 divided by 6 is the same as 90 divided by 3. And 90 divided by 3 is 30. So each of these boxes is worth 30. If that is 30, then these two would come to 60, and 30, 60, 90. There is your right angle, 90 degrees. Part B says the hypotenuse, which is the longest side, is 15 centimetres. What is the length of the shortest side? Well, I'm going to go back to my ratio, because if the angles are in this ratio, then the sides will be in this ratio as well. So I've got 1 to 2 to 3. And it says the hypotenuse, the longest side, is 15. So I'm just going to share 15 across this longest part of the ratio. So I'm going to do 15 divided by 3, which is 5. Each one of these boxes is worth 5. So this would be 15. We already know that. This would be a 5 and a 5, which is 10. And this would be a single 5. These are my 3 side lengths. The shortest side is there, 5 centimetres. Question 20, we've got the fact that there's 250 men, women and children on a train, and we've got 2 separate ratios. So men is 4 to women is 5, and then we've got a separate ratio that says women is 10 and children are 7. So these are 2 separate ratios. What we're going to try and do is combine these into one 3-part ratio. If I double this ratio, I can see that I've matched up the women part of both ratios, 8 to 10 for women and 10 to 7, 10 again for women. What that allows me to do is write a single ratio, men to women to children. The men will be this 8 down here. The women will be this matching 10. And the children will be this 7. That is now a single 3-part ratio, men to women to children. Back to the question, we know there are 250 people altogether, so I need to share 250 into this ratio. So there are 25 parts altogether. I'm going to do 250 divided by 25. And 250 divided by 25 is 10. 10 times 25 is 250. So each part is worth 10. We only want to know how many men are on the train. So there are 8 parts for men, and each part is worth 10. So we've got 80 men altogether. Question 21, we've got a probability tree diagram showing someone rolling a dice, and we've got 6 or not 6. And we're asked to complete the tree diagram. Well, first thing we need to know about tree diagrams is these 2 branches, the probabilities on them will always add up to 1. So if this is 1/6, then this is everything else, which is 5/6. If we move on to the second throw, or the second part of the diagram, well, because this is just a dice being thrown, these probabilities will match the first probabilities. So we'll have probability of a 6 is 1/6, and not a 6 will be 5/6. And then exactly the same down here. Okay, so we've got the same probabilities. What's the probability of a 6? It's 1/6. What's the probability of not a 6? It's 5/6. Part 2 says, what is the probability of throwing 2 6s? Well, that would be a 6 followed by a 6. And if we travel along that part of the tree diagram, we can collect those probabilities along the way. And what we're going to do is 1/6 multiplied by 1/6. 1 times 1 is 1. 6 times 6 is 36. That is your probability of 2 6s. Part B, we've got Cara throwing the same dice but 3 times, and we want the probability that she does not throw a 6 until her third row is 25/16. So what we're looking for is not 6, then not 6 again, and then on the third row she gets a 6. Well, if we look at my probability tree, we'd get not 6, not 6, and then we just need probability of a 6 on the end. So I'm going to sweep up this, and we'll look at probability of a 6 on the end. So we've got 5/6. We've got another 5/6. And then the probability of a 6 is the same as anywhere else on the probability tree, which is 1/6. And what we need to do is just multiply all these together. 5 times 5 times 1 is 25. 6 times 6 is 36. And we need to do 36 times 6. So I'm just going to do that over here. 36 times 6. 6 times 6 is 36. 6 times 3 is 18. 19, 20, 21. We get 216, which matches what we've got in the question. Question 22, we've got a calculation with standard form and multiplication, and it says give your answer in standard form, and this is Beth's answer. You can see here that her final answer is 12.3. Well, for standard form, this number needs to be below 10. So her answer is not in standard form. That number there is too high. Final part of this question, we've got to work out 4.5 times 10 squared added to 7.3 times 10 cubed. And we're shown that the answer is this. Probably the nicest way to do this is to convert these into normal numbers. So I'm going to do 4.5 times 10 once, and then twice again. I'm going to do this part of the calculation. So 4.5 times 10 is 45. Times 10 again is 450. That's dealt with that. I'll look at 7.3 times 10 cubed. So I'll do 7.3 times 10 once, twice, 3 times. And if I add these together, not add no is no, not add 5 is 5, 3 add 4 is 7, and 7 add 0 is 7. What I'm going to do now is convert this back into standard form. So it must be 7.75. Remember, this number has to be below 10. 7.75 times 10 to the once, twice, times 10 to the 3. This calculation and then saying 7.75 times 10 to the 3 would get full marks on this question. And final question of this paper, we're told that n is an integer, and an integer just means a whole number. We're asked to explain why 2n plus 1 is an odd number. Well, this here is timesing by 2. Writing 2n is saying take a whole number and double it. Well, when you're doubling a number, you get even numbers. Anything times by 2 will be an even number. What this is therefore saying is an even number add 1, and an even number add 1 will always be an odd number. The key to this is knowing that 2n is an even number, or the 2 times table. Part 2, write down an algebraic expression for the next odd number after 2n plus 1. Well, if we look at some odd numbers, 1, 3, 5, you'll see that there is always 2 between them. So this is saying the first odd number is 2n plus 1. What I need to do is add 2 to that, and we get 2n plus 1 plus 2 is plus 3. Final part of this question, use algebra to show that the sum of 2 consecutive odd numbers will always be a multiple of 4. Well, we've got our 2 consecutive odd numbers here. We've got the first one, 2n plus 1. And the next one is the consecutive part. Consecutive means next to each other. So I'm going to add 2n plus 3. And we just need to tidy this up. 2n added to 2n is 4n. And 1 added to 3 is 4. This is our final expression, but we're looking to show that this is a multiple of 4. And the way to do that is say, okay, look at this. This is 4 times n and 4 times 1. This is 4 lots of n plus 1. We've just factorised this expression. We've said that it's 4 times this, And if you're timesing by 4, it must be a multiple of 4.